Think about all the apps and websites you use daily, like from ordering food to streaming your favorite show. Behind almost every single interaction, there's an API, an application programming interface.
Right. Working away in the background.
Exactly. Allowing different pieces of software to talk to each other. But what does it really take to design one that's, good? It's not always about flashy stuff. Sometimes it's about being, well, surprisingly boring.
Yeah.
Okay, let's unpack this a bit. Today we're doing a deep dive into this really comprehensive guide called Everything I Know About Good API Design. And our mission here is to cut through the complexity, find those universal principles that make an API effective, reliable, and just easy to use. We're not getting bogged down in, the super technical debates.
Yeah, avoiding the rabbit holes. This dive is really designed to give you a shortcut, a way to get well-informed about something pretty critical in modern software.
Okay.
We'll look at the core philosophy, some surprising facts, and lots of practical advice. And there's this fundamental tension we'll keep coming back to. It's how API design is always trying to balance two things that seem kind of incompatible, making it familiar for the person using it and flexible for the person building it.
Okay, here's where it gets really interesting, I think. The author of our source material makes this pretty bold statement right out of the gate. Good APIs are boring.
Yeah.
That sounds completely counterintuitive, doesn't it? Like, good design should be exciting or innovative. What's the thinking there?
Well, it's all about perspective, really. For the developers building them, sure, APIs can be complex things to create, lots of work.
Right.
But for the developers using them, APIs are just tools. Simple as that. Anytime a user spends thinking about the API itself instead of what they're trying to do with it, well, that's wasted time.
Okay.
An ideal API should feel so familiar, so intuitive, that users kind of more or less know how to use it before they read any documentation.
Like, it just makes sense.
Exactly. The source mentions the Twilio API for sending texts. It's a tool to do a job. You don't want to admire the hammer, you just want to hit the nail.
So the less interesting an API is to its user, the better it actually is, because it just gets out of their way. Huh. That really flips the script on good design.
It does.
But this push for simplicity for the user, that must create a huge challenge for the builders, right? Because APIs are, notoriously hard to change once they're out there.
Precisely. Our source really emphasizes this. APIs are hard to change. Once it's published, once people start using it, any change you make that breaks things for them, that carries a serious cost.
Serious cost how?
Well, every time you force users to update their code because you changed something, they'll start thinking, maybe I should use a different API that's more stable.
You risk losing them.
Exactly. So API builders have this really strong incentive to design carefully and get it right the first time. You're always aiming for that balance. Simple for the user now, but flexible enough for you, the builder, down the road.
This strong incentive, the high cost of getting it wrong, it leads to what our expert calls a sacred duty for API maintainers, which is, we do not break user space.
Yeah, that's a powerful phrase. It's a core principle, very much like Linus Torvalds' famous slogan for the Linux kernel.
The operating system guy.
Right. It basically means you have this obligation, this deep responsibility, not to mess things up for the people who depend on your API. The source material is clear. Additive changes are usually okay.
Like adding a new field.
Yeah, like putting a new, maybe optional field in a response. Consumers should generally be built to just ignore fields they don't recognize or care about. But, and this is the crucial part, you absolutely can't remove or change the types of fields, or change the structure, like moving user.address inside a new details object or something.
Why not? What happens then?
Because every single piece of code that relies on those fields will immediately break, just stop working. And your users will be rightfully furious that you deliberately broke their software.
Wow, that's a huge ripple effect, just one careless API maintainer.
Kunal, far enough upstream, can break hundreds or thousands of pieces of software downstream. It really cascades. It means you shouldn't change an API just because it feels neater or because it's a little awkward. Stability wins.
So practicality over perfection.
Precisely. The classic example our source gives is the referer header in HTTP. It's famously misspelled. It should be referrer with 2 R's.
Right, I've seen that.
But it has been corrected. Why? Say with me.
Yeah, because we do not break user space.
Exactly. The stability for everyone using it is way more important than fixing a spelling mistake. It's a real testament to that duty.
Okay, but sometimes you do need to make a fundamental breaking change, right? Products evolve, things need overhauling. What then? The author suggests versioning, but they sound not thrilled about it.
Yeah, that's putting it mildly. API versioning basically means you serve both the old and new version of your API at the same time. Old users stick with the old one, new users can use the new one.
How do you do that?
Common ways are putting like V1 or V2 in the URL path. OpenAI does that. Or using a special header. Stripe does that, and they even let you set a default version in your account settings.
So it lets you evolve without instantly breaking everyone. Sounds like a reasonable fix. But our source says very clearly, I don't like API versioning. Calls it at best a necessary evil, but it's still evil. That's strong. Why the hate?
Well, there are three main reasons given. First, it gets confusing for users. They constantly have to check, which version am I using? Does this documentation match my version? Is my code pointing to the right one?
Okay, user confusion. What else?
Second, it's a nightmare for the people maintaining the API. If you have, say, 30 API endpoints, a new version means 30 more endpoints to maintain. Suddenly you have hundreds, all needing testing, debugging, support. It gets messy fast.
Right, the maintenance burden explodes.
And third, even if you try to be clever with translation layers between versions, those abstractions will always leak. Some changes just force you to put conditional logic, like if version 1 do this, if version 2 do that, deep into your main code, which makes the whole system more complex and fragile.
Okay, so versioning can solve the immediate problem of a breaking change, but it introduces a whole bunch of new long-term problems. Complexity, maintenance, confusion.
Exactly. The author's conclusion is pretty stark. You should only use API versioning as a last resort. The long-term pain often outweighs the short-term gain.
Got it. Okay, let's pivot slightly. What actually makes people use an API in the first place? The author drops another one of those bold claims. If your product is valuable enough, users will flock to even a terrible API.
This is a real aha moment, I think. An API is just a layer, right? It sits between the user and the product they actually want. OpenAI's models, Twilio's SMS sending, whatever it is.
You don't use the API for the API's sake.
Precisely. Nobody uses an API because the API design itself is so beautiful. They use it because they need to interact with your product. The source points to examples like Facebook and Jira, kind of famous for having appalling APIs, apparently.
Huh, really?
But people still use them. Why? Because they need to connect with Facebook or Jira. Those companies don't have a huge incentive to pour resources into perfecting the API when the product's value already guarantees people will use it, however painful it might be.
So the quality of the API becomes almost like a secondary thing, a marginal feature, as the source puts it. It only really matters if someone's choosing between two products that are otherwise identical.
Exactly. But, and this is important, the presence of an API is vital. If your product doesn't have any API, that's a big problem for technical users. They expect to be able to integrate programmatically.
That's a deal breaker for many. And the flip side is also true, right? A badly designed product makes it hard to build a good API on top.
Absolutely. A technically poor product can make it nearly impossible to build an elegant API. Because the API usually just reflects the underlying structure, the basic resources of the product.
Like users or posts.
Right. If those core concepts in the product are awkward or inefficient, the API is going to be awkward and inefficient too. The source gives this great example. Imagine a blogging system that stores comments in a really weird way, like an in-memory linked list.
Okay, that sounds bad already.
Yeah. Trying to build a standard REST API on top of that might force you into really clunky interactions. Like you might have to post to create a fetch job and then get the job status later just to retrieve comments. It forces the API user to understand way too much about the weird internal workings of the system, far more than they should reasonably have to.
That really shows how deep the connection goes between product and API design. Okay, let's get practical. What's some solid advice for building APIs that are robust but also user-friendly? Starting with logging in, basically. Authentication. Our source likes simple API keys.
Yes. Now, API keys might not be the absolute most secure method compared to things like OAuth, which gives you short-lived tokens, and the source does say you should probably support those too. But you should let people use your APIs with a long-lived API key. And the reason is crucial. Many of your users will not be professional engineers.
Ah, right. Different skill levels.
Yeah. You might have salespeople, product managers, students, hobbyists trying to use your API. For them, just copying and pasting an API key is often the easiest way to get a simple script running. It lowers the barrier to entry.
That's a great point about accessibility. Okay, what about making sure things don't go haywire if a request fails halfway through? Especially for actions like creating something or transferring money.
This brings us to idempotency. It's a bit of a technical term, but the idea is simple. The request should be safely retriable without creating duplicates.
Okay, explain that.
Imagine you're calling an API to, say, transfer $100. Your request goes out, but then maybe the network times out, or you get a vague 500 error back. You don't know. Did the transfer happen or not?
All right, the dreaded unknown state.
Exactly. If you just retry the request without idempotency, you might transfer the money twice, or
Yeah.
create two identical comments, or whatever the action was. Not good.
Definitely not good. So how do you prevent that?
The standard solution is supporting an idempotency key. It's a unique string that the user provides with their request. When an API server gets the request, it first checks, have I seen this specific key before?
What a unique transaction ID.
Kind of, yeah. If it has seen the key, it knows the action was already done or is in progress, so it doesn't do it again. It might just return the original result. If it hasn't seen the key, it performs the action and then saves the key so it recognizes it next time.
Ah, so it guarantees the action happens only once, even if the user sends the request 5 times due to errors.
Precisely. It's really crucial for requests that change things, like POST requests. Not usually needed for read requests, GET, because reading something twice doesn't hurt. Or for deletes by ID, because deleting the same ID twice has the same end result.
Makes sense.
And the source also suggests making idempotency optional in most cases. Better to get more people using your API easily, even if the occasional non-engineer causes a duplicate, than to force everyone through complex oops.
Right, balancing usability and perfection again. Now, APIs can be called incredibly fast at the speed of code, not human clicks. How do we stop people from hammering our systems accidentally or otherwise?
This is where safety and rate limiting come in. Absolutely critical. As the source says, any operation you expose via an API can be called at the speed of code. And they share this great story from Zendesk.
Oh.
Yeah, they had an API for sending notifications. Some enterprising third-party developer used it to build a real-time chat system on top, which sounds cool. But for accounts with lots of users, the sheer volume of API calls just constantly killed the app's back-end server.
Yikes. So unintentional denial of service.
Pretty much. Other common issues they saw were scripts just creating and deleting the same records over and over, maybe due to a bug, or endlessly hitting an expensive search endpoint, or trying to import huge amounts of data without slowing down when errors occurred.
So what are the defenses?
Two main things. First, put a rate limit on your API. Control how many requests a user can make per minute or per hour. Have tighter limits for operations, are computationally expensive.
Okay, throttling.
Right. And second, reserve the ability to temporarily disable the API for specific customers. Have kill switches ready just in case one user's integration goes wild and starts hammering your backend. You need a way to shut them off quickly to protect the system for everyone else.
Emergency brake.
Exactly. And it's good practice to include rate limit info in your API responses. Headers like ! remaining or retry after so well-behaved clients know the limits and can back off automatically.
Helping users be good citizens. Okay, rate limits are crucial. What about those predictably huge data sets, like lists of millions of users or tickets? You can't send that all at once.
No way. That's where pagination comes in. Just trying to select everything, like select from tickets, will blow out your available memory. You have to break it into pages.
What are the options?
Well, the simplest method is often called page or offset-based pagination. You ask for tickets.page2 or tickets.offset20 and limit 10. Easy for the server to implement initially.
But there's always a but.
But it doesn't scale well for really large data sets. With offset pagination, the database literally have to count through all the preceding records every time. So asking for page 10,000 is way slower than asking for page 2.
It's progressively slower. Not good.
Not good at all for large scale. The recommended solution, especially if you anticipate large data sets, is cursor-based pagination.
How does that work?
Instead of an offset, the client passes back a cursor. This cursor is usually the ID, or maybe a timestamp, of the last item they saw on the previous page. Let's say the last ticket ID was 32. The next request would be like tickets.cursor32 and limit 10.
Yeah.
The server then fetches items after that cursor. The query looks something like where id32 order by edlimit 10. Because database indexes are really good at finding a specific ID quickly, this is equally quick whether you're at the start of the collection or hundreds of thousands of tickets in.
So it jumps right to the spot instead of counting.
Exactly. It scales much, much better. It might be a little harder for consumers to grasp initially compared to simple page numbers, but the source strongly advises using it if your lists could get large, because changing pagination methods later is a massive breaking change. Remember rule number 1.
don't break user space.
Right.
And a helpful tip.
Yeah, a useful tip is to include a next page field or next cursor field directly in your API response. That way the user doesn't have to figure out how to construct the URL or cursor for the next page themselves. Makes it easier.
Nice. Okay, last practical point. Making responses efficient. What if some data in the response is really expensive for the server to calculate or fetch?
Good question. If parts of your response are slow or costly, maybe fetching a user's subscription status requires calling out to a separate billing system, you should make them optional.
How would you do that?
You could have a specific query parameter, like include subscription true, or maybe a more general parameter, like include subscription, profile picture. Only fetch and include that expensive data if the user explicitly asks for it.
That sounds a bit like the idea behind GraphQL, doesn't it? Letting the client ask for exactly what they need.
It shares some of that philosophy, yes. GraphQL lets users craft these detailed queries specifying exactly the fields they want, potentially across multiple related resources, all in one request.
Seems powerful, but I sense another but coming. The author isn't a fan.
Correct. The author states pretty bluntly, I don't like GraphQL very much, and gives 3 reasons.
Okay, blammo.
First, they argue it's completely impenetrable to non-engineers and to many engineers. The learning curve is much steeper than just doing a simple GT users one.
Right, back to the accessibility point.
Second, letting users create arbitrary queries makes caching much harder for the server, and you have way more complex edge cases and potential performance issues to worry about.
Because every query could be different.
Exactly. And third, the back-end implementation, building the server to handle those complex queries efficiently and securely, is often so much more fiddlier than building a standard REST API endpoint. So while acknowledging it has its uses, the author would only use it where I absolutely had to.
Interesting trade-offs there between client flexibility and server complexity. Now, we've mostly talked about public APIs, facing outwards. What about internal APIs, the ones used just inside a company between different teams? Are the rules different?
Yes, some key assumptions definitely change. For internal APIs, your users are usually other professional engineers within your company.
Right, you know who they are.
You typically have far fewer users than a public API, and crucially, you often have the ability to coordinate changes. You can go talk to the team using your internal API, maybe even help deploy the updated code on their side.
Ah, so breaking changes are less catastrophic.
They can be managed more easily. It might be possible to safely make breaking changes through coordination. You can also usually require as complex a form of authentication as you want, because your internal users can handle it.
But some rules still apply.
Oh, yes. Internal APIs can still cause major incidents if they fail, and things like idempotency for critical actions are still just as important internally as they are externally.
Yeah.
Still don't want internal systems accidentally duplicating orders or payments.
Okay, that distinction makes sense. We've covered a lot of ground here.
Right.
From that core idea that good APIs are boring because they're predictable.
To that really critical, we do not break user space rule.
And we looked at practical tools like idempotency keys, cursor pagination. It really highlights how much thought goes into this hidden infrastructure that we just, take for granted every day.
It really does. And the recurring themes are clear. Empathy for the user, always prioritizing stability, and thinking about long-term maintenance rather than just what seems neat or clever right now.
It's about building solid, predictable tools so others can build their things.
Exactly.
So what's the main takeaway here for you listening in? Whether you're deep in code, managing products, or just curious about how this digital world works, understanding these principles really shines a light on the hidden design choices shaping your online experience.
It shows that so much of the quality we perceive comes from this careful, sometimes unglamorous back-end work.
Absolutely.
And maybe this raises a question for you to think about. Knowing now just how much effort goes into keeping APIs stable, into avoiding those breaking changes, how does that change your perspective when a service you rely on does change things? Or when you run into an API that feels a bit clunky?
Do you see the trade-offs now?
Yeah. Do you maybe appreciate those boring, stable APIs a little bit more, knowing the sacred duties involved in keeping them that way, something to mull over?